The Western Aleutians represent one of the most remote areas of the world. Because of this, the volcanoes in this island chain remain poorly studied. An expedition to this remote region was launched in September 2015, with funding from the U.S. National Science Foundation, with additional support from the U.S. Geological Survey and the Deep Carbon Observatory.
The goals of the expedition included investigating of how Earth's crust forms, how magma composition and volatile content affect eruptive activity, and how much volcanic carbon is emitted to the atmosphere.
To study the gases emitted from volcanoes requires sampling of the fumaroles. There is no easy access into the active crater of Garraloy.
We decided to climb down into the crater over very slippery tephra layers on top of old snow and ice. It took us several hours to reach the fumaroles.
When we finally got there, I started collecting altered rock samples from this pristine and extreme environment for microbiological analyses. Deep Carbon Observatory deep life scientists are currently analyzing these samples. They're interested in finding out what kinds of organisms thrive in acidic, high-temperature environments adjacent to fumaroles.
The heat of the gases emitted from these fumaroles reached 350 degrees centigrade. Kiska was the westernmost active volcano that we collected gas samples from. Its emissions came from a single huge fumarolic vent covered in native sulfur. The gas emissions sound like jet engines, and descending into the big vent seemed way too dangerous given our remote location.
Another target we visited was Kanaga volcano, which has an extremely steep edifice, requiring the helicopter to land right on the summit. Dan, our very skilled pilot, was able to drop us right next to the approximately 15-meter wide fissure that opened up during the 2012 eruption.
Here I am sampling some of the low-temperature gases from this fissure, while Taryn collects plume samples for CO2 content and carbon isotope analyses.
After sampling these gases and collecting plume samples, we analyzed them on board of the Maritime Maid using a thermoscientific delta ray isotope analyzer. Obtaining results while still in the field allowed us to adjust our sampling protocols in real time.